Thank you for taking the time to learn about our world-changing, cutting-edge technologies. What you're about to see in this presentation are the most advanced energy generation, energy storage, and on-demand releasable energy solutions the world has ever seen. And we're pleased to invite your involvement to help us make a real difference in the world. Our technologies are now on their way to delivering the most energy-efficient solar power solution anywhere in the world. This is evidenced by the head of the U.S. Department of Energy 2020 Sunshot Program's response to us, stating that our solar collection and storage technologies would be notable advances over state-of-the-art. And best of all, we're able to deliver our solutions 7 years ahead of the DOE 2020 Sunshot Program going into effect, while having exceeded the expectations they requested. We can deliver 24/7 baseload energy from solar at below fossil fuel prices. We can solve global grid issues with clean baseload energy that is dispatchable on demand, and we can do this more efficiently using less than half the land area of all other solar solutions, completely free of pollution, delivering electricity at below fossil fuel pricing. Our solar solution integrates more than 3 dozen patented improvements in solar collection, energy storage, and power generation. The result? The lowest cost per kilowatt in 24-hour solar power. Our amazingly lightweight heliostats collect and deliver solar energy in a concentrated beam to a central thermal reactor. Our compact calcium hydride reactor efficiently stores excess energy for use in times of peak energy demand. And our ultra-high efficiency Stirling engine generator set converts heat to electricity. Each of these innovations is significant in its own right. Combined, revolutionary. Just 6 hours of sunlight will store 18 hours of pure energy, producing 24/7 continuous energy powered only by the sun. Our heliostat is a 25% improvement over other heliostats and was designed to be lighter weight and lower cost to manufacture. Today, this technology has 4 times the efficiency of photovoltaics. The first installation will be a 3,600 kilowatt-hour solution with 6 large heliostats concentrating sunlight into the thermal reactor. This can fit onto about 1 acre of land and produce 100 kilowatts of power 24/7, or burst up to 500 kilowatts for a few hours a day by using more than one Stirling engine. We have more than a dozen patented improvements on the Stirling engine technology alone. With greater efficiency than that of diesel systems, we're able to cleanly and quietly produce electricity on demand from any energy source that produces heat. One of the innovations was to integrate an extremely low-friction diamond graphite-based coating into the engine's drivetrain, eliminating the need for wet lubricants and providing for a no-touch solution, a 5-year maintenance-free engine. This engine can have countless applications to many other industries, increasing productivity over existing technologies by providing useful work with greater efficiency and reducing costs on each application with our Stirling engine's 5-year maintenance-free capability. Although our patented Stirling engine improvements are revolutionary all on their own, when combined with our solar collection and storage technologies, our efficient energy generation capabilities become greater than any other similar technologies in use or under development anywhere in the world. Our heliostat collects and concentrates the sun's rays, reflecting the light 3 times to create a 2.5 meter beam of sunlight aimed at the reactor. Using off-axis parabolic down mirrors, the beam is then reflected a 4th time, focusing the beam to the equivalent of 7,200 suns into the calcium hydride reactor. The mirrors have a front-facing silver coating in addition to a self-cleaning surface, delivering up to 98% reflective efficiency per mirror. Let's look at how this works. It's rather elegant in its process with only 2 moving parts. During the day, the sunlight passes through the quartz window, shown here as number 1, into the calcium hydride reactor. Calcium hydride heats up to over 1,000 degrees Celsius and outputs heat via the heat pipe, number 2. directly into the Stirling engine, number 3, which outputs 100 kilowatts of power. Multiple Stirling engines can be used if a larger volume of energy output is required during peak periods. When the sun heats the calcium hydride, hydrogen is released and, contained within the system, the pressure rises. The pressure pushes the hydrogen through the boron oxide thermocline tank and cools the hydrogen in the process. See number 4. The hydrogen continues its journey into 144 hydrogen storage tanks, relieving its pressure as it deposits as a solid titanium iron hydride. See number 5. When the sun goes down, the temperature and the pressure drop within the calcium hydride reactor. This reverses the hydrogen course, and the hydrogen is reintroduced into the calcium hydride reactor. The hydrogen reacts with the calcium in the reactor to form calcium hydride, releasing heat, which drives the Stirling engine, generating electricity. Electricity is generated continuously as the hydrogen flows back into the reactor throughout the night. The next day, this process repeats. The only thing exiting the system is heat via the heat pipe to power the Stirling engine. This is a revolutionary self-contained system producing electricity with zero pollution and with just 2 moving parts: the cover to the quartz windows that seals the reactor at night and the Stirling engine. Solar to electric efficiency is targeted at more than 36%, where other concentrated solar power projects are only showing 15 to 18% efficiency. Our Stirling engine is better than 49% efficient, our solar capture is over 81% efficient, and our energy storage is 92% efficient, performance above and beyond all other solutions. In addition, our solution has 18 hours of storage, whereas all other technologies offer zero energy storage, except 2. One with 2 hours and another building 7 hours of storage. Our 3600 kilowatt-hour system occupies only 1 acre. Our 10 megawatt version, shown here, takes up just half the land space of other world-leading solutions, none of which includes energy storage along with energy production. Levelized cost of electricity accounts for all costs associated with producing electricity. We've designed our system to exceed 20-year life, so every year above 10 years lowers the levelized costs of electricity even further. In conclusion, we have introduced you to our patented breakthroughs in solar collection, thermal storage, and our Stirling engine. How the design will use half the land requirements of other concentrated solar power solutions, and how we can deliver baseload energy at below fossil fuel prices. We have provided you with an insight as to how we create baseload energy that can be dispatched on demand instantly. Because of our uniquely durable design, we have lowered the maintenance requirements over all other solutions as well with our no-touch systems. And best of all, our systems can be placed in any remote location where power is unavailable or where clean, renewable power at below fossil fuel pricing is preferred. Thank you for viewing our presentation today. We appreciate your interest in our technologies and would like to hear from you. If you would like to become involved, to share in having a real impact on the world's green energy future, or simply wish to receive further information about the ADI companies, please contact us using the information on the contacts page of this website.